Hey there. We're going to be looking at 9.1 that covers interval notation and linear inequalities in this video. So we're going to begin with solving linear equalities. So we have an example here of we have 3x plus 3 is less than 2x minus 1. So recall that inequalities are going to involve one of these symbols rather than an equal sign. So less than, this is greater than, or you might see less than or equal to, and then greater than or equal to.
Oh, okay, sure.
Okay. Sorry about that, I got interrupted. So inequalities are going to involve less than or greater, oops, I didn't finish that sentence, or that expression, greater than, less than or equal to, which is when you have the bar underneath, or greater than or equal to, also with the bar underneath. So this is an inequality. 3x plus 3 is less than 2x minus 1. We're going to solve it and we're going to graph the solution. So I'm basically just going to be doing some examples in this video. And so what we need to do is we have x's on both sides of our inequality. We're going to solve this just like as if it were an equation, except for putting an equal sign in, we're going to keep that inequality symbol. One thing you do need to remember when you're solving inequalities is any time that you divide or multiply by a negative number, you have to flip the direction of the inequality sign. All right, so we're going to get our x's on the same side here. So what I'm going to start doing is I'm going to subtract the 2x. And the reason I'm subtracting 2x rather than subtracting 3x from both sides is because now 3 minus 2, I get 1x on this side, and it's positive. And it's just kind of nice to avoid negatives when you can. 2x minus 2x is 0, so I'm just left with negative 1 on this side. And then continue solving. We're going to subtract 3, and I end up with x is less than negative 4. So this is my solution. X is less than negative 4. Now I'm going to, that's one way to write it. That's writing the solution in inequality form, but there's multiple ways we can do it. We're going to write the solution in set notation right now, and then I'm also going to show you how to write solutions in what's called interval notation, and then how to graph it with interval notation. So you may remember if you've solved inequalities in the past, that when you graph it on a number line, we used an open dot, an open circle if a value is not included. Like for this inequality, x is less than negative 4, so negative 4 is not included. So graphically, we would use an open dot. If it's included, we fill it in, and that means it's included. And that would be when you see this bar underneath the inequality symbol, that means it's included. All right, so let's look at set notation here. So for set notation, you start with a fancy bracket like this, and then you name the variable that we're talking about, which is x, and you put a bar, and then you just put the inequality. And then you close the other side with another fancy bracket like that. So that is called set notation. And so it's important to know all the different notations, because depending on what textbook you pick up or who you're listening to, what teacher you have, they might use a different notation. So interval notation is what is commonly used in, like, when you get to pre-calculus or calculus. So we're going to learn that. And just like you have an open dot for not included and a closed dot for included, with interval notation, you're going to have round parentheses to indicate something is not included, and you're going to use square brackets to indicate something is included. So, for example, if you have this inequality, x is less than 2, we're not including 2. So to write that in interval notation, what we're going to do is we're going to go from the lowest number that's possible to the highest, and you put a comma and go to the highest number that x can be. And so our lowest, since x is less than 2, that goes all the way to negative infinity. So negative infinity, you can never get to negative infinity, so it really can't be included. So anytime you're dealing with infinity, you're going to have a round parenthesis around that side. And then you put a comma, and the highest x can be, since x is less than 2, it can be up to 2, but not including 2. So we're going to put that around parentheses. Now you can't say negative infinity up to positive 1, because you're missing an infinite number of numbers between 1 and 2. Because you have like 1.1, 1.2, 1.9, 1.9999999, all the way up to 2, but not including 2. Okay, so then let's look at some inequalities, their interval notation, and how you graph them using interval notation. So we just did the x is less than 2. So my boundary point is this 2. So you may be used to the dot, and then if it's less than 2, we shade this way. Well, with interval notation, this is how you do it. Instead of a dot, you're going to put because 2 is not included, we're going to put a round parenthesis, and we're going to face it this direction because it's those values that we are including for our solution. This is helpful. You don't have to do that shading like this because it's clear which way we're talking about. It's all the numbers that are this direction from positive 2. This is read as x is less than or equal to 2. So now we're going, the lowest number that it can be, since it's less than 2, is still negative infinity. So we have round, parentheses, up to 2. This time 2 is included in the solution. So we're going to make a square bracket instead of a round parenthesis. So then you guys try to pause the video and do these next 2 examples, see if you can get it. Check your work. So for this next one, x is greater than or equal to negative 3. So the lowest number is negative 3, including negative 3, and x is anything greater than that. So we're going, the lowest is negative 3 up to anything bigger than negative 3, which doesn't have an endpoint. You can go all the way to infinity, but I'm going to use a round parenthesis at the other end because it can't be, you can't ever reach infinity. So you make that square bracket. It's all those values that direction. You really don't need to draw this line that I'm drawing because the direction of the square bracket indicates which way, which values we're talking about. So then x is greater than negative 3 is going to look very similar, but it's going to be a round parenthesis. Okay, next, write the solution in interval notation and graph. So we're going to solve this and write the solution in interval notation, and then we're going to graph it. So I need to, there's a couple different ways you can do this. We could start, so I'm going to rewrite this. So I have 3 times 2x minus 4 minus 7x is less than or equal to negative 3x. All right, so we have a lot of simplifying that we need to do on the left side. I'm going to start by distributing that 3. I get 3 times 2x is 6x. 3 times the negative 4 is minus 12 because I have a positive times a negative. And then continue on, I got negative 7x, or minus 7x is less than or equal to negative 3x. Now I have 2 like terms on the left side of the inequality. So I'm going to combine those terms. 6, you add your coefficients. 6 is the coefficient here, and negative 7, this negative is with that 7x. 6 minus 7 is negative 1x. I don't need to write the 1, I could just write negative x, but I have it there, so I'm going to leave it. Is minus 12, because I still have this guy, is less than or equal to negative 3x. Now, I said earlier that we want to avoid negatives. I could add x to both sides, but if I add x to negative 3x, it's going to be a negative 2x. So you may want to do this. It wouldn't be wrong to do that. You just have a negative that you have to deal with. And then when you're solving, you've got to remember to flip the direction of the sign. I'll do it both ways. So if I add 3x here, I'm going to get negative 1 plus 3 is positive 2x. And then on this side, negative 3x plus 3x is simply 0. So then continuing to solve that, I would add 12. Add 12. I'm moving over here. I got on this side, I'd have just 2x because the negative 12 plus 12 adds to 0. And on this side, I have 12. And then if I divide by 2, I get x is less than or equal to 6. So when I graph that on a number line, you want to make your number line convenient. So I'm going to put a 6 right in the middle here. And it always goes like a number line, regular number line. It's going to go up. It's going to increase in values from left to right. And it's all the values less than or equal to 6. So I'm going to draw a square bracket because it's included. And then if you want to write this in interval notation without the graph, we're going from negative infinity, not including negative infinity, up to 6, including 6. All right. So why don't you guys try to solve this? This is a little bit different because we're solving for y. We have two variables. I'm just going to get y on one side by itself. So I'm going to do this one with you. If you want to try to do it on your own, you can. So I want to get this term by itself, this negative 3y. So I'm going to subtract the 2x from both sides. So 2x minus 2x, that's going to add to 0. So I have negative 3y is less than 6 minus 2x. And then I have negative 3 times y, so I'm going to divide by negative 3. When I do that, I have to divide every term by negative 3. And then remember what I said, when we divide by negative, we are going to need to flip the direction of that sign. So this becomes negative 3 over negative 3 is just y, and then I'm going to make that a greater than symbol. Positive 6 divided by negative 3 is negative 2. And then I have a double negative here. I have minus 2x divided by another negative. So you can think of that as like a negative 2x divided by a negative 3. So it becomes plus 2x over 3. And that's solved for y. We're not actually getting like an answer. We're just getting a relationship. We have a relationship between x and y, and we just solved it for a different variable. Okay, and then the last example for 9.1 that I'm going to do, I want you to read this to yourself and see if you can think of how you might set this up. Okay, I kind of cut off that last sentence, but so you purchase X shares of stock at $12 per share, and then 6 months later you sell it for $20 per share. So you're making $8 per share 6 months down the road. Your broker charges you $15 for the trade. So that's just a flat fee. So there's a one-time deal. If your profit is at least $3,985, how many shares did you purchase in the first place? So your profit is your revenue, which is how much is coming in, minus your cost, which is how much is going out. Our revenue is what we sell those shares for, which is $20, and we don't know how many shares, so it'd be 20x. We'd write an expression for that. Our cost is up front, we paid $12 for those X shares. So it's going to cost us 12x, and then it's also going to cost us $15 to pay the broker for making the transaction for us. So our profit, we want to have our profit, which is we get by taking our revenue minus our cost. We want at least $3,985. We want our profit over here to be greater than or equal to that. So our revenue minus cost needs to be greater than or equal to this value. So my revenue is 20x, and then I'm going to subtract, and you have to put this in parentheses because you're subtracting both of these costs. So I end up with, if I solve this, I get, I'm going to distribute a negative, so you can put like a 1 there if that helps, but we're subtracting both of these terms, and subtraction means to add the opposite. So we have to subtract how much we spent on the shares themselves, and we also have to subtract the cost of paying the broker. And so then if we continue solving this, you solve it and check your work. So we combine our like terms after we distribute that negative. 20 minus 12 is 8x, minus 15, we add 15 to both sides, and you get 4,000 is less than or equal to 8x. Divide by 8, and x is greater than or equal to 500. You purchased at least 500 shares. If you purchase more than that, then you could make, we want to figure out how much it would take to make at least that much. So x has to be 500 shares or more. All right, that is 9.1.